In the last segment, I introduced temperature. And remember, we have Fahrenheit, Celsius, and Kelvin. So these formulas on how you convert between Fahrenheit, Celsius, and Kelvin, you need to commit to memory. Okay? So this segment is going to start with a derived unit, which is density. And density being derived means you go out and you measure a mass, you measure the volume, you divide the two, and you derive density. So the mass unit is typically grams. Volume unit is typically a milliliter or cc. Cc is cubic centimeter, but not always. And we'll see that when we get to gas laws. And density is density regardless of the sample size. Okay, this is important to remember. So, since you have a unit in the numerator and a unit in the denominator, this should alert you that densities can function as conversion factors, and they do. Sometimes you just go and look density up in a chart somewhere. Sometimes you have to figure it out yourself, hence derived unit. So this question is a question like that. What is the density of a substance with a mass of 1.25 grams that occupies a volume of 1.25 milliliters? Well, density is mass over volume. So you simply divide the two. And oftentimes in beginning chemistry classes, there are labs where you get some substance and you measure its mass, you measure its volume, and then you are asked, what is this substance likely to be? This is a very good example of how you take something that you don't know, that's an unknown, and compare it to something that you do know, which means that you need to go find a density table of known values and compare. And when you would do that, you would find that the density of your unknown, 1.25 divided by 1.25 is 1.00 grams per milliliter, and you compare that to your known chart, and you would find that this is likely to be water. Okay, it's likely to be water. And there are many things that look like water, so you would do some more tests. You wouldn't necessarily drink it because there are all kinds of things that look like water that could poison you. Yet, nonetheless, the idea is if you have an unknown, you compare it to something that you do know to get some information about it. Okay? Now, the other thing is that the density of water is a factoid that you should just remember. Density of water is 1 gram per milliliter, okay, which is the same as 1 gram per 1 milliliter. Okay, so what that means is that you can use this as a conversion factor in going from mass of water to volume of water. Okay, here's another one. An unknown has a mass of 1.25 grams and a volume of 0.967 milliliters. What is the density? Density, 1.25 grams, 0.967 milliliters. Okay, so 1.25 divided by 0.967, 1.293, 1, 2, 3 sig figs here, 1, 2, 3 sig figs here, 1, 2, 3 sig figs. So we're going to call that 1.29 grams per milliliter. Okay. And then the application is, what is the density? Okay, here it is. Is this likely to sink or float when mixed with water? Okay, sink or float. Well, first of all, it's not going to be water because the density is much higher. Since the density is higher, your 1.29 grams per milliliter will sink and your water will float. Okay? All right, next page. Explain your answer. Okay, I think I got that already over here, so I'm not going to reinvent that. Mercury has a density of 13.6 grams per milliliter. So that would be something that you would go and look up. Okay. What is the volume of 5 grams of mercury? Set up using a starting place, ending place, and use density as your conversion factor. Okay, so picking out your starting place, density is density regardless of the sample size. So whether I have this much mercury or this much mercury or this much mercury, it's all going to have the same density. So density is usually not a starting place. Your starting place is here. 5 grams of mercury, that's the symbol Hg. You could write mercury if you want. What is the volume? So you need a volume unit over here. I would choose milliliter because that's the volume that you have here. Okay? And now you're just going to use your density to get out of grams and into milliliter by canceling or using the factor label method like we did before. 13.6 grams, milliliter, grams are going to cancel. Units, 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 units. Repeat 15,000 times. Okay, when we're in the classroom, I say that to students. Repeat this 15,000 times. And of course, I don't mean that literally, but the things that I'm telling you over and over and over again are your tips on how to be successful. Okay, so we have 5 divided by 13.6. We get 0.368. 5 divided by 13.6. Going to check it twice. 1 sig fig here. 3 sig figs here. This is measured and derived, so we have to count. So we're limited to 1 here. This rounds up. 0.4 milliliters of mercury, or Hg is the symbol for that if you want. Okay? Next question. You want 100 grams of Au, which is gold. Okay? Notice I have the decimal. So that's telling you, the reader, that I want 3 significant figures. If the density is 19.3 grams per cc, what volume would you have? Remember, a cc is a cubic centimeter. Okay, starting place is 100 grams of gold. Ending place is a volume unit. And since you have cc here, you should have cc there. Then you're going to use your density, just like you did before, as a conversion factor. Grams in the denominator, cc in the numerator, so the 19.3 goes in the denominator. Make your units cancel. cc here, cc there. Okay? So 100 divided by 19.3, 5.181. Okay, I'm going to try again. Always check your answers twice. Okay. 3 sig figs here, 3 sig figs here, 3 sig figs here. Okay. All right, and the last one is a concept. Which has a greater density, a big pile of gold or a small pile of gold? Neither, because density is density regardless of the sample size. So if I have this big pile of gold, the density is 9.3 grams per cc versus my little pile of gold. Density is density regardless of the sample size. Okay, again, 10 or more problems on each of these topics before moving on. All right, so this is the end of Unit 1. Okay, so by now you should be doing your homework. You should be doing practice exam. You should be watching any other videos and working book problems. Also, if your course has them, be sure that you're doing your warm-ups as directed. Okay, and then you're going to be ready for Exam 1.